Next, the world's most advanced telescope took another leap forward this afternoon as its mirrors were unfolded a million miles from Earth. NASA's James Webb Observatory is the successor to the Hubble Space Telescope. NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. Far beyond the reach of human sight, the James Webb Space Telescope fixed its gaze on a seemingly unremarkable patch of sky and returned with images and data that forced NASA to sound the alarm. What Webb revealed was not merely another galaxy cluster or the signature of a distant exoplanet, but something so profoundly unexpected that NASA issued a red alert. This wasn't routine caution or technical jargon. It was a direct acknowledgement that something in the depths of the universe had defied all predictions and forced scientists to reconsider assumptions they had held for decades. The scale, the structure, and the very nature of what Webb detected carried implications that reached far beyond astronomy into physics, cosmology, and even humanity's place in the cosmos. Before we start, smash the like and subscribe buttons for more updates. The James Webb Space Telescope was designed for discovery at the very limits of light, peering into epochs of cosmic history never before observed. Its unprecedented sensitivity allowed it to capture light stretched across billions of years, revealing the first stars and galaxies that flickered into existence after the Big Bang. Yet, in this instance, Webb uncovered signals that didn't belong to that expected story of early cosmic formation. The telescope detected objects that appeared impossibly massive, structured, and bright, existing at a time when, according to standard models, the universe should have been too young to allow such complexity. What should have been small, primitive gatherings of gas instead showed the fingerprints of fully formed galactic systems, as if cosmic time had fast-forwarded billions of years in defiance of every established model. The implications of such a finding were staggering. For decades, cosmology had been underpinned by a timeline. The Big Bang, followed by a gradual cooling, the condensation of hydrogen into stars, the slow buildup of galaxies, and eventually the large-scale structure of the universe. But Webb's deep field observations suggested that the universe had achieved maturity in its infancy. Galaxies that should not exist so soon after the beginning of time were sitting there in the data, their light unambiguous, their presence undeniable. If verified, this would mean that our understanding of dark matter, dark energy, and the very physics that governed early expansion would have to be rewritten. NASA's red alert was not simply a warning for astronomers to pay attention. It was a recognition that Webb's discovery had overturned one of the central pillars of modern science, the cosmological constant, the equations of general relativity as they pertain to universal expansion, and even quantum models of particle interactions. In the earliest seconds of existence suddenly seemed incomplete. The telescope had unveiled not just galaxies, but a paradox, a cosmic riddle written across the sky. Equally astonishing were the signals Webb picked up in wavelengths that hinted at chemical signatures far more complex than expected. Within the atmospheres of distant exoplanets, and even in interstellar gas clouds, Webb's instruments detected elements and compounds usually associated with biological processes or advanced chemistry. These weren't definitive signs of life, but they suggested that the raw ingredients for life may have been far more abundant and available far earlier than scientists had ever imagined. To encounter such complexity so soon in cosmic history raised unsettling questions about how common life might truly be in the universe, and whether civilizations perhaps vastly older than our own could have risen and fallen long before Earth itself formed. NASA's response reflected the gravity of the situation. This was not a simple discovery to be cataloged in journals and left for gradual analysis. A red alert meant that teams across the world were mobilized, telescopes coordinated, and data poured over by specialists in fields ranging from astrophysics to particle physics. There was urgency because the discovery did not sit neatly within any known framework. If Webb's detection held true, it would ripple into questions about the stability of physics itself. Could the constants we had always assumed unchanging, the speed of light, the gravitational constant, the behavior of quantum fields, be variable over cosmic scales? Could the very laws that underpin our understanding of reality shift depending on epoch or location? The possibility that natural law itself was not fixed but dynamic introduced staggering implications. It suggested a universe not as a uniform stage governed by timeless equations, but as a living, evolving system where the rules themselves could adapt. If galaxies could emerge in an impossible epoch, then the processes driving them might belong to a physics we have not yet even begun to grasp. Such a realization carried not only scientific weight, but also philosophical magnitude. Humanity had long believed it was approaching a grand unification of physics, a final theory that tied together the smallest particles and the largest structures. Yet, Webb's discovery suggested that the universe was not a closed puzzle waiting to be solved, but an ever-deepening mystery with layers of reality still beyond reach. The red alert also underscored the vulnerability of our assumptions about cosmic order. For decades, the standard model of cosmology had been remarkably successful. Observations of the cosmic microwave background, surveys of galaxy distributions, and studies of dark energy's influence all seemed to reinforce the model's reliability. But Webb had shown that even the most successful models could crumble when confronted with data from the universe itself. This was a reminder that science is not a monument of certainty, but a living dialogue between observation and theory, where even the most cherished equations can be humbled by new evidence. At the same time, the implications extended beyond abstract physics. If complex galaxies existed far earlier than thought, then black holes, those engines of cosmic evolution, may have been seeded almost instantly after the Big Bang. The presence of massive black holes in such early galaxies suggested a mechanism of growth and collapse far more rapid than any theory currently allowed. These black holes would not only reshape galaxies, but potentially influence the fabric of space-time itself, creating ripples and distortions that Webb's instruments might now be beginning to perceive. The gravitational wave signatures from such ancient events could hold secrets about the very moment of cosmic birth. And then there was the darker possibility. Some theorists speculated that what Webb saw might not be galaxies at all, but structures of an entirely different nature. Exotic objects predicted by speculative physics, such as primordial black hole clusters, cosmic strings, or regions of space where different physical laws reign, could manifest as unexpected signals in Webb's detectors. If this were the case, then the telescope might have stumbled not upon an anomaly within our model of the universe, but upon evidence of realities that branch beyond our own dimensions or domains where space-time itself takes on unfamiliar forms. The red alert symbolized more than discovery. It symbolized disruption. It was a call to scientists and humanity alike to face the possibility that the universe is stranger, faster, and more unpredictable than anyone dared imagine. It forced a reconsideration of our timeline, of the origin of matter, and of our own trajectory within this vast cosmos. If life could have arisen so early elsewhere, then we are not unique. If the laws of physics themselves are in question, then even the foundation of technology and knowledge may rest on shifting ground. The James Webb Space Telescope had already been hailed as a window into the beginning of time. But in this moment, it became something more, a mirror reflecting back the fragility of human understanding. NASA's alert was not a gesture of panic, but of humility, a recognition that what had been detected lay outside the boundaries of present comprehension. It was both a warning and an invitation, a reminder that the search for knowledge is not a path toward final answers, but a journey through ever-unfolding layers of wonder. In the glow of that red alert, one thing became unmistakably clear. Humanity now stood on the threshold of a new cosmic narrative. The universe had spoken through light carried across billions of years, and what it said was simple yet profound. We do not yet know the full story. The unimaginable had been glimpsed, and it was only the beginning. The images that streamed back from the James Webb Space Telescope shook the foundations of everything scientists thought they understood about cosmic history, where the darkness of deep time should have shown only faint glimmers of infant stars. Webb revealed entire sprawling structures that should not have existed. The red alert issued by NASA was not the language of routine discovery, but the acknowledgement of a rupture, a fault line cracking through the very models that guided our comprehension of the universe. It was the moment when the cosmos itself revealed that it is far less obedient and far more complex than humanity's calculations had ever anticipated. The magnitude of this revelation begins with the nature of Webb's design. Built to replace the Hubble Space Telescope, Webb was engineered with precision instruments to see the faintest traces of light stretched across cosmic time. Its golden hexagonal mirrors captured infrared wavelengths, enabling it to pierce the thick shrouds of dust that had hidden the earliest epochs of the universe. Where Hubble's vision faltered, Webb's sight sharpened, offering a window into the first hundreds of millions of years after the Big Bang. This was supposed to be an era of cosmic simplicity, an age of chaos just beginning to congeal into order. Yet, the data told another story. The telescope had unveiled galaxies shining brightly, some so mature in structure that they seemed to mock the very timeline of creation. The shock was not confined to their existence, but extended to their sheer mass and scale. These objects were not wisps of hydrogen clustering into fragile stars. They were colossal gravitationally bound systems teeming with billions of stars already organized into coherent spirals and elliptical forms. Such structures should have required billions of years to assemble under the standard cosmological model. To see them fully formed at a stage so close to the universe's birth was like watching a child grow into adulthood within a single day. The incongruity could not be reconciled with existing theory. The red alert signified that the discrepancy was not minor. It demanded an overhaul of the entire framework. Scientists pored over the data with urgency. Every pixel of Webb's deep field images was scrutinized, every spectral reading analyzed. The red shifts of these galaxies placed them at distances corresponding to times mere hundreds of millions of years after the Big Bang. The precision of Webb's instruments left no room for error. Either the galaxies existed at these epochs, or the very method of measuring cosmic distances and expansion was flawed. Both possibilities carried staggering consequences. If the galaxies were real, then galaxy formation must proceed at a pace unimaginably faster than current physics allows. If the red shifts were misleading, then our interpretation of cosmic expansion and by extension the Hubble constant and the role of dark energy was incomplete or even wrong. Beyond structure, Webb's spectrographs uncovered chemical complexity that defied expectations. Heavy elements such as carbon, oxygen, and nitrogen were found in these ancient systems. Conventional models of nucleosynthesis held that such elements were forged in the hearts of successive generations of stars, building slowly over eons. Their presence in such abundance at this early stage suggested that the universe had accelerated its chemical enrichment process to an unimaginable degree. This raised questions about the potential for life, for chemistry itself, to emerge vastly earlier in cosmic history than once believed. If planets could form in these environments, and there was no reason to doubt that they could, then the seeds of biology might have been sown while our own galaxy was still in its infancy. As researchers grappled with these findings, speculation expanded into uncharted territory. One hypothesis suggested that the fundamental constants of nature may not have been as constant as once thought. If the strength of gravity, the speed of light, or the values of particle masses varied slightly in the early universe, then processes that should have taken billions of years might have unfolded with incredible rapidity. In such a universe, galaxies could assemble almost instantaneously. Black holes could grow to monstrous proportions overnight, and stars could forge heavy elements with astonishing efficiency. Webb's discoveries hinted at a cosmos not bound by immutable rules, but one whose laws evolved with time, shifting in ways that humanity had not yet begun to measure. The red alert was also a recognition of potential observational contradictions. While Webb's instruments confirmed the presence of these massive early galaxies, the cosmic microwave background, the fossil radiation left over from the Big Bang, told another story. For decades, the microwave background had been the bedrock of cosmology, a snapshot of the universe as it was mere hundreds of thousands of years after the beginning. Its patterns matched beautifully with theoretical predictions of inflation, dark matter, and dark energy. Yet, if galaxies of this scale existed so early, then the microwave background may conceal subtleties that had gone unnoticed. Perhaps hidden within its fluctuations were signals of new physics, relics of a universe more dynamic and unpredictable than the smooth patterns once suggested. Some theorists turned to exotic explanations. Could these ancient signals be the fingerprints of primordial black holes, seeds left behind by processes during the Big Bang itself. If such objects had existed, they could have rapidly accreted matter and catalyzed galaxy formation far earlier than expected. Another possibility was the existence of structures such as cosmic strings, hypothetical filaments of immense energy stretching across spacetime. These relics of symmetry breaking in the early universe could have acted as gravitational scaffolds, accelerating the clumping of matter into galaxies. If Webb had stumbled upon evidence of such exotic physics, then the telescope was not merely revealing galaxies, but uncovering the fundamental architecture of spacetime itself. The consequences of these revelations extended beyond astrophysics. If life could have emerged in the earliest galaxies, then the universe may be teeming with civilizations far older than ours. The very notion of advanced life takes on new dimensions when considered against a timeline where intelligence could have arisen billions of years before Earth even coalesced. Civilizations may have risen, flourished, and vanished in epochs so remote that their light has only now begun to reach us. Webb's instruments sensitive to atmospheric signatures of distant worlds hinted at the possibility of identifying biosignatures across the galaxy. The detection of such signs within ancient star systems would not simply change science. It would alter the story of humanity's place in the cosmos. NASA's red alert also carried a symbolic weight. It was an acknowledgement that humanity had crossed into territory where the known boundaries of knowledge could no longer be trusted. This was not an incremental adjustment to theory, but a confrontation with mystery itself. The tone of urgency reflected the recognition that Webb had not merely expanded our field of view. It had destabilized it. The universe had revealed a face that was older, stranger, and faster than any model had prepared us for. The red alert was a call not just to scientists, but to civilization itself to prepare for a paradigm shift. The data forced a rethinking of cosmic chronology. Instead of a slow unfolding of complexity, the early universe now appeared as a crucible of hyperactivity, forging galaxies and stars at a furious pace. This new vision of cosmic history suggested that the timeline of evolution, both physical and potentially biological, might be far more compressed than once thought. If this is true, then the possibility that life is abundant throughout the universe gains strength as the window for its emergence is vastly larger. Humanity's uniqueness would diminish, replaced by a vision of a cosmos rich with countless beginnings. The scale of implication also extended into the realm of technology and exploration. If the laws of physics themselves varied across cosmic time or space, then new technologies could emerge from their study. Understanding how gravity or particle interactions shift under extreme conditions could unlock principles that defy current engineering limits. Concepts once relegated to science fiction, faster than light travel, energy extraction from exotic matter, manipulation of spacetime itself, might find footholds in the new physics suggested by Webb's discoveries. NASA's alert was not only about astronomy. It was about the dawning recognition that the universe itself may hold pathways to a technological future unimagined. The red alert also reminded humanity of its fragility. For all the triumphs of science, for all the equations etched into chalkboards and the simulations run on supercomputers, the cosmos had revealed its indifference. It did not conform to expectation. It did not bow to the certainty of human logic. The galaxies Webb revealed existed whether or not our theories allowed them to, shining as testaments to a reality more profound than thought alone could grasp. In their light, humanity was humbled, reminded that discovery is less about mastery and more about surrender. Surrender to the vastness, the unpredictability, and the mystery of existence. In the quiet halls of observatories, scientists returned again and again to Webb's images. They traced the spirals of galaxies that should not have been, measured the brightness of stars that should not yet exist, and calculated the chemical signatures of elements that should have taken billions of years to form. Each measurement confirmed the same truth. The universe was outpacing theory. Every piece of data was both a revelation and a rebuke, telling humanity that the cosmos is not a puzzle to be solved, but a story forever unfolding, always one step ahead of comprehension. The issuance of a red alert marked the crossing of a threshold. For centuries, science had marched forward, building upon the foundation of Newton, Einstein, and countless others, steadily refining its models. Webb had not merely refined, it had shattered. In the silence of space, across distances so vast they defy imagination. Light had traveled for billions of years to deliver a single message. The story is not what you thought. And as the world looked skyward, it became clear that this was not an ending, but a beginning. A new era of discovery had dawned, one where the unimaginable was no longer a distant dream, but a present reality. Webb had revealed the universe in its raw, untamed form, a cosmos alive with secrets demanding to be explored. The red alert was not a warning of danger, but an invitation to wonder, a call to step beyond the boundaries of knowledge and into the boundless expanse of possibility. The James Webb Space Telescope was never intended to confirm what humanity already knew. It was designed to expose what had been hidden. In the wake of NASA's red alert, the reality became clear. Webb had uncovered evidence that did not just stretch the imagination, but pulled apart the very seams of modern cosmology. What it saw in the abyss of deep space was not only unexpected, it was unimaginable. Structures, signals, and anomalies that spoke of a universe with rules and histories far stranger than earthbound theories could grasp. This was not a refinement of knowledge, but an invitation to abandon familiar frameworks and enter uncharted intellectual territory. One of the most immediate shocks came in the form of light itself. The galaxies and celestial phenomena Webb detected radiated with an intensity out of proportion to their assumed age. In theory, galaxies at such early epochs should have been dim, their stars only beginning to form from clouds of hydrogen and helium. Instead, the telescope revealed objects blazing like cosmic beacons with luminosities rivaling some of the most mature galaxies in the nearby universe. This discovery forced scientists to confront an unnerving possibility. Either the physics of star formation is far more efficient than previously believed, or these objects draw their energy from mechanisms that lie outside conventional astrophysics. Among these mechanisms, one speculation stood out with extraordinary weight. Some researchers proposed that these luminous galaxies might be powered not solely by stellar processes, but by exotic forms of matter or energy that remain undiscovered. If true, this would place Webb's findings at the intersection of astronomy and fundamental physics. The telescope could be witnessing signatures of phenomena that hint at dimensions beyond the visible, energy fields not yet understood, or interactions between matter and spacing that break the boundaries of Einstein's equations. Such possibilities were radical, but the data demanded explanations as radical as the observations. Equally profound was the revelation of order where chaos should have reigned. The infant universe was thought to be turbulent, filled with clumps of matter still jostling into structure. Yet Webb's images revealed galaxies exhibiting defined spirals and organized elliptical patterns. To see such symmetry so soon after the Big Bang was akin to witnessing a masterpiece painted before the canvas had even dried. This level of order implied that gravitational organization and cosmic architecture may unfold on timescales far shorter than previously thought, perhaps influenced by unknown forces guiding matter into coherent forms. The universe, it seemed, was predisposed toward order, a revelation with consequences for both physics and philosophy. Another threat of astonishment lay in the atmospheres of distant exoplanets. Webb's infrared instruments identified chemical fingerprints in planetary systems orbiting stars thousands of light-years away. Molecules like methane, carbon dioxide, and even traces of water vapor were detected in places and at concentrations far earlier than conventional models predicted. This suggested that planets capable of sustaining complex chemistry and potentially life were forming much earlier in cosmic history than scientists ever imagined. If these planetary systems existed at a time when the Milky Way itself was still in its infancy, then the likelihood of ancient biospheres elsewhere in the universe grew exponentially. Life may not be a rare latecomer in the cosmic story, but an early frequent occurrence woven into the very fabric of the universe. The philosophical implications of such a possibility are staggering. If intelligence could have arisen in these ancient galaxies, civilizations billions of years older than ours might have had the opportunity to rise, evolve, and disappear long before humanity's first steps on Earth. Their artifacts, technologies, or signals might still drift across the cosmos. Faint echoes of societies that predated Earth itself. Webb's findings reopen the question of cosmic neighbors not as speculation, but as an inevitable extension of observation. If the conditions for life appeared early and abundantly, then the question is no longer if we are alone, but how many came before us and whether any remain. As scientists wrestled with the implications of early galactic maturity and planetary atmospheres, another frontier emerged in the form of gravitational signatures. Webb sensitivity allowed it to observe distortions in light caused by massive unseen structures. Some of these distortions suggested concentrations of matter so extreme that only black holes of extraordinary size could explain them. Yet these black holes seem to exist far earlier than theory allowed. For a black hole to reach millions or billions of solar masses requires long time scales of accretion. To find such giants in the infant universe defied logic. Either the processes of black hole growth were astonishingly accelerated, or these objects were not born from stars at all, but from direct collapse phenomena in the very early universe. If the latter is true, then black holes may be as fundamental to cosmic structure as galaxies themselves, perhaps even predating them. This discovery carried with it another unsettling implication. The very fabric of spacetime may have been shaped from its inception by these titanic gravitational wells. If black holes arose alongside the Big Bang, then their influence may stretch back into the first fractions of a second, altering the course of cosmic evolution in ways we cannot yet model. It even raises the possibility that black holes are not introducts of cosmic collapse, but building blocks of the universe itself, seeds around which matter organizes and light bends into the architecture we observe today. The red alert was not just a message for scientists. It was a signal to humanity that we stand at the edge of intellectual transformation. The universe had unveiled a narrative beyond our textbooks and equations. And the challenge now was not to dismiss the unimaginable, but to confront it. For philosophers, the findings called into question the presumed linearity of cosmic order. For theologians, the discoveries stirred reflection on the origins of life and the scale of creation. For technologists, the anomalies hinted at principles that could one day be harnessed in ways still inconceivable. The telescope had not only looked into the past, it had projected humanity's imagination into the future. One area of speculation centered on the possibility of variable constants. If the rules of physics were slightly different in the early universe, then perhaps processes of star formation, chemical enrichment, and gravitational assembly occurred at a pace unimaginable today.